Okay, so definition momentum everybody knows from O levels. Now, momentum is mass into velocity. Product of mass into velocity. So definition is given there. This file is there is in unit 5. Unit 5 folder notes. Go to notes, click on notes. You will see unit 5 and unit 5 you will see that. I got a notice from my bank. Wait, let me pause it. Resume recording. Fine. Formula of the momentum, you guys know mass into velocity, and you know that unit is kg meter per second, okay, or Newton second. Why Newton second? Anyone idea? Anybody has any idea regarding that? Why it is Newton second? I'll let you guys know why it is Newton second. It's an impulse. Okay, the momentum change in momentum is impulse, and impulse is force into time. If I'm not wrong, why it is Newton second? I'll let you guys know it. Okay. Now let me just see this over here. Okay, fine then. Newton second. Fine. So it's a vector quantity. It's a vector quantity because velocity is a vector. So momentum is a vector quantity. You guys are supposed to know that also. Why? It has direction. Amra O level porsi right side e gele positive, left side e gele negative. Okay, fine then. Example number 1. Okay, let's start. Everybody, you guys know this. Huh? The momentum is conserved after the collision. All of you know that part. Momentum is conserved after the collision. So whatever was the momentum before the collision, the same momentum has to be after the collision. So if they ask you what is the laws of conservation of momentum, you have to write it down. Here it is not written that the sum of the total momentum before the collision is equal to sum of the total momentum after the collision. Okay. So what is a loaded supermarket trolley of unknown total mass is rolled into a stationary stack of 2 empty trolleys. So you have a one single trolley and you are pushing it into empty trolley, but that trolley is loaded. One of the trolley is loaded. So this is a loaded trolley. You don't know how much is over here, how much you kept in the trolley, but you are pushing it towards 2 trolley which are joined together. Find 2 empty trolleys. They are empty also. Each of mass 8 kg. So this is going to be 16 kg, right? And this is going to be 16 kg plus there is going to be some unknown mkg as well, because it is loaded. We don't know how much is loaded with. What kind of mass it is loaded with. We don't know that, right? Okay. Okay. Before they link together is 2.2 meter per second, and speed of the link trolley after the collision is 1 meter per second. So this joined with this again now after the collision. So what actually happened? This is after the collision picture. You have this trolley with mass in it, and you have rest 2 trolley as well. So understood? Okay. So now what is it? Around 24 kg, right? But you also have the mass with you. Fine. Okay. Link to trolley is okay. And what is their speed? Final speed? 1 meter per second. Okay. Now, at what speed did you throw that this thing? Calculate the mass of the shopping trolley. Okay. Trolley's unknown mass is rolled into a stationary stack of 2 empty trolleys, each of mass 8 kg. The speed of the loaded trolley before the link is 2.2. So before they link it is 2.2, and this mass is how much? Sorry, what is the speed here? 0 meter per second. So you understood before the collision picture and after the collision picture? Guys, bro, what will be the 8 kg? That will be 8 kg, 8 plus x. Which one? Yes, this is going to be 8 kg and it's going to be 8 plus x. This part. It's not 16. It's going to be 8 kg. Okay. So this is going to be 8 kg. Okay. Understood, everyone? Okay. So now can you guys do this for me? I think you guys know after this what to do. Before the collision and momentum find karo. After the collision and momentum find karo, equal to each other karo. Give me the value of m. I want to know the value of m over here. And what mass was the trolley loaded? I think you guys can do it. Pause the recording, please. So you guys all were able to get the answer for this to be 5.33 kg. And I hope all of you know how to do that equation. This is momentum before the collision is 8 plus m into 2.2. And momentum here before the collision is going to be 0. Right? Equals to momentum after the collision. After the collision is going to be 24 plus m into 1. Then you need to solve it. So let me show you how it is done. You can check that over here. Can you see? Momentum before the collision part. Just check. Momentum before the collision and momentum after the collision. And this is 5.33 kg. Understood? Shall I put that? Okay. Let's go to the next one. Okay, now this is about some wood and this arrow. Okay, so I want you guys to read this, form a solution, and give it to me. Otherwise, I will do it for you. Don't worry. Just read it. Try to form a solution. Acha, previous sum with everyone, is it over? Previous sum with everyone, is it over? You guys got 5.33?
Yes.
Okay, fine then. Chalo, then you guys start doing this one right now for me, please. Charge. Okay. I'm sorry, I have to pause the recording. So you guys will be able to do this. So you guys were able to do this as well. Okay, fine. Very good, everyone. Now, these are something you guys are supposed to know. The conservation of momentum can be tested by using gliders on an A track. Now, I'm going to show this to you, but whether I will record this or not, I don't know, because the frame rate decreases anyway. So most probably I will not be able to show this because in the recording it doesn't. All you can do, go to YouTube. I'll show you the YouTube link. Just go there and watch it on your own. Jara online also. Man in the sense so remember, if you guys know gliders, we learned about gliders. Now we know O levels, gliders, and we learned about A track. Jara A track or glider ke byapare jane na. Okay, oderke amake ekhon shikate hobe. How many of you know about gliders and A track? Those who saw my motion videos will know this. I think in motion videos I recorded them. I'm not sure, by though. I'm not sure. Okay, so I'm going to show that gliders and this thing right now with you to show if you want to know whether the momentum has been converted or not, you need a glider and A track. I think, Bhaiya, can't I do with normal trolleys, which we do? The normal laboratory, there are those are there, not the small cars are there. Problem with those cars and all, small cars for to test out momentum is they have friction. So momentum is only conserved when there is no external force acting on them. Okay, if there is an external force such as friction, momentum is not conserved. Remember that. Now let me show you that this thing, this gliders things and all. Okay, let me try to find that video. Pause the recording. So now those who are seeing me online, I mean this class, recorded class, please go to YouTube and check for this video over here. Verifying principal conservation of momentum with an A track. Okay, just write this and I'm pretty sure you will end up getting this video. Very good video, to be honest. I'm not recording it because there is always drop in frame rates. That is the reason. Okay, so let me show you guys what gliders. I'm pretty sure everyone who did their O levels with me knows what gliders and A tracks are, right? Okay, now those who didn't, let me teach you guys. Okay, I'm pausing the recording. So after watching the video, I actually found an important diagram which all of you should draw. Okay, this is how the conservation of momentum experiment is carried out. You have a glider, you know what the gliders are. You have an A track, you have an air from the blower, you have a card. This card cuts through light gate. You know how does the light gate work, and it measures the time for you. Then you have a pin. The pin will join the blue tack. Okay, and they both will go together. Then when they're going together, again there is a second light gate. You can see there is a second light gate, this one. Okay, there is a second light gate, and the second light gate, the time will get measured again. This is the first light gate where only single, this one's time will get measured. So then you can find momentum before the collision and momentum after the collision, and you can see whether it is conserved or not. Please do draw the diagram. Okay, I'm pausing the recording now. So era bolte se, in practice, external force such as friction acts on the object. I told you that. There is a reason we were using a glider which had no friction. Why? Because it was floating, almost floating. And you must have seen those in those games. Remember I told you guys games that air hockey, you call them? Air hockey. Air hockey game ase na? If you guys have played that game, you know how does that disc floats on top. And it is very smooth. I don't know how many of you actually played that in malls and all. Okay. But the force which is perpendicular, like tumar momentum jodi edike hoy. Okay. Ar tumar jodi weight is perpendicular to the momentum direction, na? Can you see? This is your weight. It is perpendicular to your momentum. It can be ignored. Anything that is perpendicular to the direction of the momentum can be ignored. So our friction can be taken into account, but weight cannot be. Why? Weight can be ignored because it is perpendicular to the direction of momentum. Online, সবাই বুঝছো কিনা বলো এই প্যারাগ্রাফটা সবাই understood? Nafisa? No, friction perpendicular. Nah, that's the reason we take friction into account. Friction is important. But we know, did I say that weight is important? For conservation of weight is not important. Weight can be ignored because it is perpendicular to the direction of momentum. বলো উপর নিচে যদি হয়, that term I don't know, that term I have to say. Okay, no, in that time if the collision is vertical, that means it is due to the gravity only, na? So that means your weight is acting as a force. Yes, that time it can. Okay, তুমি বলছো না, আমি আচ্ছা, repeat what I said before this. When something is perpendicular, if the collision is vertical and if your momentum is also vertical, your weight is vertical, are they perpendicular now? So that means weight is a significant factor over there. Friction is this direction, okay, and your momentum is also this direction, so it is perpendicular, sorry, it is parallel. So friction is a important factor, weight is not. Why? Weight is perpendicular, that is the reason. বুঝছো this thing তুমি বুঝছো বিবেশা? নাফিসা, মেহেক, তারপর সুজি, কায়েস, মারিয়াম, পান্না, সবাই বুঝছো কিনা বলো? হ্যালো? Okay, fine then. Now let's talk about impulse. Impulse তোমরা জানো is force into time. Force into time. It's like when two objects are colliding, for fraction of a second they touch each other, na? When they collide, like আমি যদি এই যে ক্ল্যাপটা করতেছি এখন, এটা যদি আমি স্লো মো করি, for fraction of a second my right hand and left hand is touching each other, na? That point you are applying a force on each other for some amount of time. That is known as impulse. Okay, that is known as impulse. Impulse এর ফর্মুলা কি? Impulse এর ফর্মুলা হচ্ছে force into time. Impulse এর ফর্মুলা কি? Force into time. Okay, now এখন let me derive a formula for you guys. F is equal to m into a. এই জায়গায় তুমি v minus u by t দিতে পারো, আর তুমি what is this? This is known as change in momentum. This is known as change in momentum. So change in momentum এর ফর্মুলা কি? Force into time মানে impulse. Impulse এর আরেকটা নাম কি? Change in momentum. But if you want force, can I bring the time on the other side and write mv minus mu divided by t? What is this? This is rate of change of momentum, because নিচে একটা টাইম আছে, টাইম থাকলে ডিভিশনে যদি টাইম থাকে, we write rate. This is known as rate of change of momentum. সবাই কি বুঝছে? This is rate of change of momentum. Rate of change of momentum আরেকটা নাম কি? Force. আর শুধু change in momentum এর আরেকটা নাম কি? Impulse অথবা force into time. Online, everyone clear this one?
Yes.
Okay, chalo then. You guys know how to derive this formula now then. F is equal to m into a jagah v minus u by t. Tar bracket equal to mv minus mu. What is mv minus mu? Change in momentum. What is mv minus mu divided by t? Rate of change of momentum. Now let's talk about how to explain this. Okay, let's talk about two ice skaters. Okay, pushing each other. Let's for example be Biasha and Sanjay. Let's say for example. Okay, for example, they're playing ice skating together. Okay, they pushed each other like Viviasha, you know how she push করছে. Okay,
don't give me example.
so if you push me right now, that will be also an example of changing momentum. যখন তুমি আমাকে ধাক্কা মারো না, momentum zero ছিল. When you applied a force on me, my momentum changed. Same thing here. When they were stationary, two ice skaters, they are stationary, but they pushed each other. And you know the ice is very smooth, it has very less friction, so you will move really smoothly apart from each other, just like even Bangladesh. Achha, okay, whatever. Two ice skaters push each other as they move apart. Both man and woman have the same force. Okay, they're pushing each other. Now let's say box A is pushing box B and box B is pushing box A. Newton's third law, two bodies. Newton's third law, two bodies. Every action has equal and opposite reaction, but in opposite direction. They are pushing each other in opposite direction. Overall change in momentum of the man, okay, is equal but opposite direction to the change of momentum of the woman. So woman er change in momentum and man er change in momentum is same but in opposite direction. What is that? Why? They are pushing each other in opposite direction. So their change in momentum. Change in momentum মানে কি? Impulse. আমি তোমাদের বলছি না impulse is also vector quantity যখন momentum করাচ্ছিলাম m1 এ যে এর impulse যদি পজিটিভ হয় এর impulse কি হবে? নেগেটিভ হবে। বুঝছো? All of you have a read at this right now. All of you read this for a line. Let me pause the recording. Now, so this is an important, another important point we're going to learn. Area under the force time graph. তুমি যদি force আর time এর কোনো graph draw করো, let's say this is the force time graph. Area under the graph is okay impulse. Because what is area under the graph? Let's face it, we are going to calculate it in terms of box na. Area of the box ki force into time hi to hobe na. And what is force into time? Impulse. So area under force time graph is impulse or change in momentum. Because impulse is after word ki change in momentum. Okay, impulse is equal to change in momentum আমি লিখে দিছি আর তোমাদের এখানে ফর্মুলা সব লিখে দিছি ঠিক আছে। Now let me go to the next page. There you go. I have this. We did this now just now. Yes. Now let me do this sum with you all. Let us copy. Okay, let's continue. A net force on or a resultant force is required to change the body's momentum. I told you this. Just now I was giving BBS example. Like my momentum was zero. Like right now I'm not moving. If she would have come and pushed me, our momentum I got zero. Okay. But once she pushed me, she applied a force on me, right? What would be my momentum? It would change, na? Basically, I would go like 2 kilometers back. I mean 2 meters back. Okay, I would go 2 meters back, na? So my momentum would be changing, na? You're getting my point, what I'm trying to say here. Okay, listen. Okay, see, so they said a net force. So you need a resultant force for a momentum to change. Now, when a net force for a period of time acts on a body, net force acts on a body for a period of time, the impulse applied by the force, the impulse is equal to body's change in momentum. I just showed you this. This you guys know. So force is equal to rate of change of momentum. You guys know this. Now let me do this sum with you all. Okay. So in this sum, what did they give? They give above graph shows momentum of two railways, truck A and B varies when they collide in a railway sliding. Okay, so they are colliding in a railway sliding. Okay, was it a railway or was it a truck or whatever it is? Okay, now calculate. Now they showed you. Now can you see? Look at the railway A over here. Look at railway A over here, and this is railway B. In railway A, can you see this was the initial momentum? Okay, and this is the what? Final momentum. Can you see this? And here somewhere there was a what? Collision. Understood what I'm trying to say? There was a collision. After the collision, what happened? There is a change in momentum. So তোমার truck এর momentum কমে গেছে আর truck B এর momentum কি? Can you see? বেড়ে গেছে না? Yeah. এখান থেকে এখানে যত time, same এখান থেকেও এখানে তত time, because they both were in contact with each other for the same amount of time. I told you. Impulse for both the body is same. Change in momentum for both the body is same. The momentum for both the body before and after collision is also same. The total momentum. Now, let's say if this height here, এর যত height কমছে, can you see? এর তত height কি বাড়ছে. Okay, truck এর momentum কমে গেছে, তো truck B এর momentum কি বাড়ি গেছে. Okay, what did they show here in the y-axis? A momentum. Don't think this is velocity. What is this? Momentum. Understood? And x-axis ki dise? Time dise. How much time were they in contact with? They were in contact with each other for this much second. What is it? 1 minus 0.64. Clear? Online? Everyone? Okay. Online, everyone. Clear this concept, na? Other momentum. The horizontal line is their momentum. Truck air momentum decreased. Truck B momentum increased. Hello, online. Suji, Haider, Nafisa, sorry, Haider, Nafisa, Mehak, everyone. What's up? Panna, Mariam. হ্যাঁ সবাই ঘুমাচ্ছে মনে হয় আমি জানি না দেখি তো আমি তো প্রিয়ামেশের মতন বোরিং না আমি তো ওই বিবিএসের ব্যাপারে জোক ক্র্যাক করতেছি আচ্ছা রেকর্ডিং আছে yeah they all are active সবাই তো okay now they said calculate the force that the truck A exerts on truck B. I need to know the force is what? Rate of change of momentum. Force এর ফর্মুলা কি? F is equal to mv minus mu divided by t. আচ্ছা এখানে mv minus mu তো দরকার নেই because ওর mv তোমাকে দিয়ে দিছে কত এগুলো 10 to the power 3. Can you see? Yeah, okay, let's see the of truck A. Truck এর সব ভ্যালু দিয়ে দিছে. What is the final momentum of truck A? 30. ঠিক আছে, minus v mv minus mu. What is the initial momentum of truck B? 60. Sorry, truck B না, truck A final momentum কত? No. Final minus initial. Sorry, divided by time. How much time did it take? 1 minus 0.64. How much is 1 minus 0.64? 0.36. 0.36. Okay, fine. So to me, final minus initial, but you have to multiply both of them by 10 to the power 3, na? Because what's your y-axis? Y-axis koto? Whatever value you have to multiply it by 10 raised to 3. So eta kore tumra, huh? Here I'm doing 30. Final minus initial. So final is 30. My initial is 60. Understood? So I did that. Let me go to the next page and just show you guys. Let me stop the recording. Okay. Copy. Again, I'm 60 minus 30, but I did 5. It has to be 30 minus 60 actually. Where is my paint koi? No, I can paste. Done. Can you see the calculation here, all of you? Change in momentum, 30 minus 60 or 60 minus 30, 10 raised to 3, and so and so. Okay. Now, next question they are asking me, the force on truck A by B. Remember, whatever force B pushes A with, A also pushes the B with equal and opposite direction. So I can put that. So I put some. Okay, fine then. Now let's continue. So it is equal and opposite. Eta ami 83,000 করছি ওটা ওখানে দেখে দাও। এটা আমি 83,000 করছি, এটা হবে minus 80 কি 3,000. It's a wash form. Put it over there. Here okay. First beta find karo, eta find karo, but A on B and B on A is going to be same only, na? Equal and key opposite. Very good. Now next one. There are two forces. The two forces are equal in size but in opposite direction, as we would expect from Newton's key third law. Okay, now let's talk about rockets now. Let's talk about rocket. Why does a rocket go up? Because one of the reasons the rocket goes up is again by using conservation of momentum and Newton's third law. Is that you have a rocket, for example. Okay, you have a rocket, and rocket is, what does the rocket do? It ejects gas downwards, right? It is pushing the gas downwards, and the gas pushes the rocket upward. Okay, so both of them are key momentum key change hoche. Total momentum key age momentum ki chilo before pushing the rocket? 0. After the momentum of the rocket is equal and opposite of momentum of the gas. ঠিক আছে? Both the momentums are same but in opposite direction. So final momentum key, একটা positive একটা negative. Final momentum key 0. Understood? That the final momentum is 0. সবাই কি বুঝছে online? Final momentum 0 এটা বুঝছো কিনা বলো? কি? Okay then. A rocket is ready to take off. It ejects the waste gases. In this situation, conservation of momentum takes place. যখনই তোমাকে দুইটা বডি পুশিং ইচ আদারের ব্যাপারে বলবে এরকমই লিখতে হবে, শুধু গ্যাস আর রকেটের জায়গায় বডিজের নামগুলো লিখতে হবে বাস, ঠিক আছে? So they said both the rockets and gas experiences equal and opposite forces. Rocket and gas experiences equal and opposite change in momentum. Okay, the total the total energy always gets conserved, but the kinetic energy is not always conserved. But total energy always gets conserved. Total energy is also conserved. Okay, এটা জানার দরকার নাই তোমাদের। এই ইলাস্টিক কোলিশন, ইনইলাস্টিক কোলিশন তোমাদেরকে মনে শিখাবে, but it is there only in class 12. 11 এ এটা পড়াবে না, 11 এটা করাবে না, ঠিক আছে? So let me see if there are other more pages are here or not, or this is the last page. Okay, there are other pages. We have some rocket related questions. So remember, total energy is always key conserved. Total energy is always conserved. এটা মনে রাখিও তোমরা। Okay, a rocket is ready for takeoff. It ejects waste gases. The result of the exploding of mixture of oxygen and hydrogen at the rate of 1.2 10 to the power 4 kg every second. So what is the rate at which it is putting the gases out? 1.2 10 raised to 4 kg every second. Find that. If the exhaust speed, okay, is 4 into 10 to the power minus 3, calculate the upward thrust. They want the force from you. This is a very tricky question. So let me show it to you. আমরা ফোর্সের ফর্মুলা কত? আমাদের ফোর্সের ফর্মুলা কত? m v minus u by k, t না? আচ্ছা, এই t টাকে আমরা, can we bring this t over here and now it becomes kg per second? উপরে কি দিছে আমাকে? kg per second দিছে না? মানে কি mass by t? তো এখানে অটোমেটিক্যালি কি হয়ে যাচ্ছে? mass by t. এই mass by t এর জায়গায় can I automatically keep 1.2 10 to the power 4? আর ইনিশিয়াল ভেলোসিটি কত ছিল? 0। ফাইনাল ভেলোসিটি কত? 4 into 10 to the power 3, 0। সবাই এটা বুঝছো কিনা বলো? Because ওরা বলছে kg per second. If you write, you can write this also like this, and এখানে তুমি কি লিখতে পারবে? 1 second ও লিখতে পারবে, না লিখলেও চলবে। সবাই কি এটা বুঝছো বলো? নাফিসা, মেহেক, সুজি, পর্ণা, মরিয়ম। Hello guys, huh? Hello, say something. I'm pausing the recording. They wrote, by Newton's third law, the upward push of the ejected gas on the rocket is equal in size but in opposite direction to this. It is 48 meganewton, a force big enough to lift a mass of 4,800 tons. So 4,800 tons. Okay, whatever. So momentum, এতটুকু তোমরা অনেকে momentum concept বুঝে গেছো, right? If I want, now what I'm going to do is, I'm going to do a bit of textbook revision with you all, then I will give full textbook question answers to you. Okay, including the answers. Answers ও দিয়ে দিব তোমাদেরকে, ঠিক আছে? Yeah, fine then. I'm pausing the recording.